So you want to know how to do minimum path sum. Well, you came to the right place. So let's get to it. So it says, given an m by n grid filled with non-negative numbers, find a path from top left to bottom right, which minimizes the sum of all numbers along its path. Well, what is it without them putting words between? Well, what happened to the? What's up with these LeetCode descriptions? So aside all of that, you can only move either down or right at any point in time. Find a path from the top left to the bottom right, moving only down or right. So they show here that to get from here to there, the shortest sum is 1 plus 3, 4, plus 1 plus 1 plus 1 equals 7, which is smaller than 1 plus 1, 2, plus 4, 6, plus 2, 8. Oh, that's already bigger than 7. So we need to find, once again, the smallest, minimizes. So we want a min function. Those who know my videos, which is maybe, hey, one person, know that I like writing a max and min function when available. And the reason is it gets me into the groove. And it doesn't take long. So that's it for the min function. Then what exactly are we doing? Well, we know that this is 1 is the smallest path from everything that goes, let's see, that's the minimum that you could get here, because it's the minimum of 1 plus right, which does not exist, and 1 plus down, which does not exist. But this 2 over here, while the minimum to get to with 1 included, and we can't have any values below, is 2 plus 1, which is 3. So you already know that it's 3 here. And at any given point, it's the minimum between whatever it is plus right or whatever it is plus down. So at this point, we take the minimum from this plus this, or the minimum, or this plus that. That's what it would be. Here, the minimum we could get is 2, because it could only go down. 1 plus 1 equals 2. So at this point, it would have to choose between 2, which is that, or 5 plus 2, which is that, which is 7, or 5 plus, and this would be 3 at this point. This one would be 3, because that's the smallest you could get from here. So 5 plus 2 or 5 plus 3. It would choose 5 plus 2, and here the shortest path as of this point would be 7. So you get the idea. It's another dynamic programming problem. Okay, let's just do a little, just move the cursor there, a little sanity check. If the grid is empty, then return 0. You can't get anything after an empty grid. Then we want to immediately start working out of this box over here. So if, let's see now, so we're going to loop going like this from down here, then here, and then here. And at each point, we're always going to have our value. So if, let's see now, so for int I equals grid.size minus 1, I bigger or equal, because we're going down, then 0, I minus minus, we're starting at the top, which is really the bottom. This is an abstract representation. For int j equals grid 0 dot size minus 1 again, also j bigger or equal to 0, and j minus minus. Okay, so at any given point, we're looking for the min between the two paths if they exist. And how do we check if they exist? Well, okay, so let's see if they don't exist. So let's see now. If I plus 1 bigger than, equals grid dot size, that means we've already gone overboard. And j plus 1 equals grid 0 dot size. That means we have nothing to play with, and so we do nothing. So let's just assign it to itself. grid, let's just have, yes, I know that's redundant and I could have done it the opposite direction. Actually, you know what? We don't need that. Let's just save that for last. Let's start here. So if I plus 1 smaller than grid dot size and j plus 1 smaller than grid 0 dot size. So that means we have two values here. That means grid, let's see now, grid I j equals, now it's the minimum, my min of grid I j plus grid, what is this, I plus 1 j, or right after that comma, or plus I j plus 1. Okay, don't try this at home, kids. Okay, now if, so if only one of them exists, if I plus 1 smaller than grid dot size and let's see now, what is this? And j plus 1 equals grid 0 dot size. So we only have the I plus 1 available, meaning going down. Grid I j equals, then we don't need any min here, so it would be this over here. Okay, else, okay, sorry, we wanted else if okay, so here we want the contrary, so if I plus 1 equals grid dot size and j plus 1 smaller, then we take grid I j equals, actually we could just do plus equals, so we want that j plus 1 there. Okay, yeah, so that's good over there. And actually, let's just do that same nomenclature over here. Let's just make that a little cleaner here. Okay, so we have that. And if they're both not there, then actually we don't need to touch anything. So at the end of all this, we should return grid 0, 0. And if this miraculously works, I'd be surprised. Oh, okay. We have a winner. Well, that's it, folks. Have fun.